Okay, lesson 3.2, chain rule with exponentials and logs, including bases other than e. So we're going to apply the chain rule to exponential and log functions using some formulas. So given that u is a function of x, so some kind of like x squared plus something, or just some other function in there, okay? Then since the derivative of e to the x equals e to the x, then it follows that the derivative of e to the u equals e to the u times the derivative of u, right? So that's our chain rule. Also, since if we have the derivative of the natural log of x equals 1 over x, then if we take the derivative of the natural log of u, where u is a function of x, then it's equal to 1 over u times the derivative of u, or we can write it as u prime over u. Okay, so we're going to go through and look at what happens if we have a base other than e. Okay, so if I have the derivative of a to the x, I can rewrite that as the derivative of e to the natural log of a to the x power. Okay. And then using a log property, I can rewrite that natural log of a to the x to x times the natural log of a. Okay. And then applying the chain rule, e to the u, right, is going to be maybe e to the x to natural log. Let's fix that. Of a times the derivative of x, natural log of a, derivative of x is just 1. So, and then natural log of a is just a number. So we're going to just get that natural log of a. Okay. Now using our log property in reverse, I can rewrite e to the x times the natural log of a as, let's see, e to the natural log of a to the x times the natural log of a. Okay, using that inverse property now, I can rewrite this as a to the x times the natural log of a. So, if we take the derivative of something to the x power, okay, it doesn't matter what base it is, it's going to equal a to the x times the natural log of a. And that's our chain rule, right? Like that's if it's just a number like 2 to the x power. Okay, if we have some function u there, right, then it's a to the u times u prime times the natural log of a. Let's see a couple examples. Okay. Another way is using the change of base formula. So if I have log base a of x, I can rewrite that as the natural log of x over the natural log of a. And we can take the derivative of this, right? So I rewrite it, and now we have a quotient. Okay, and it says that we get 1 over the natural log of a times the derivative of the natural log of x, since the natural log of a is a constant, right? It's just a number. So I can just pull that out front, right? And then the natural log, the derivative of the natural log is 1 over x. So we're going to have 1 over the natural log of a times 1 over x. Okay, so if I'm taking the derivative of a log, then we get the 1 over the natural log of that base times 1 over x. Same thing applies with that chain rule if it's a u. Okay, some function, right? That's what the u is a function of x. Right, then it's u prime over u times the natural log of a. Okay, let's look at some examples here. So f of x equals e to the x squared plus 3x. Okay. My x squared plus 3x, that's that u, that function of x. So I need its derivative. Okay. So the derivative, right over here, of x squared plus 3x is equal to 2x plus 3. So our derivative of f of x is going to be our e to the x squared plus 3x times our derivative of x squared plus 3x, so 2x plus 3, right? So it's e, I'll change colors there. E to the u times u prime. Okay. Well, let's look at a natural log. Okay, so g of x equals the natural log of 3x, and it says use the derivative of natural log of u equals u prime over u. Right, so our u is at 3x. So the derivative of 3x is just 3, right? So that's that u piece. U. That's my u prime. Okay. So our g prime of x is going to equal u prime, so 3, over our u, 3x. Color this so we can see those pieces. Okay. Right. So we got to make sure we're taking that derivative of the inside. Okay, I don't know why it didn't leave a space. So for 3, it says g of x equals the natural log of 3x. Use that the natural log of 3x is equal to the natural log of 3 plus the natural log of x. Okay. Well, if I'm going to take, we're going to just draw an arrow up here, the derivative of g of x, right? So I take each piece. Well, the natural log of 3, that's just a number, so I get 0. Right? Plus the natural log of x, its derivative is 1 over x. I failed to mention over here on my number 2, right? 3 over 3x, that simplifies to 1 over x. Okay, so either way we look at it, we get the same answer, right, for 3 and number 2. Okay, let's look at number 4. So number 4, I have y equals the natural log of t squared plus t, right? So that t squared plus t is our u function. Okay. So the derivative of t squared plus t is going to be 2t plus 1, right? So then go back to our function. Y prime is going to be, and I'm going to look at it where we've got our u prime, right? So we're going to have u prime over u. So the natural log of t squared plus t, its derivative is 2t plus 1 divided by t squared plus t. Okay, let's look at number 5 next. Number 5, we have h of x equals x times the natural log of x, right? This is a product, so I have to use that product rule. So h prime of x is equal to the first times the derivative of the second plus the second times the derivative of the first. And I'm going to simplify. So I get x times 1 over x, that's 1. The natural log of x times 1 is the natural log of x. Just coloring those different so you can see those two. Okay. For number 6, we've got g of t equals e to the negative 3 over t. Right, so that u piece is that negative 3 over t. Okay, but I'm actually going to rewrite this so that we get e to the negative 3 times t to the negative 1. Right, that power is going to make it a little bit easier to take the derivative. So g prime of t is going to be e to my negative 3 over t times, right, the derivative of negative 3t to the negative 1. So I drop my power, so negative 3 times negative 1 gives me a positive 3. And t to the negative 1, I reduce that by 1, so to the negative 2. Okay. Could kind of simplify this, right, as e to the negative 3 over t times 3 over t squared. That works too. Okay. Next, let's look at number 7. I've got 3 to the square root of v. So I'm going to rewrite that square root of v. So we get 3 to the v to the 1/2. Okay. So right, we have our base is 3. Okay. And the derivative, okay, for something like this is going to be the base to our u times u prime times this is the natural log of a. So I'm going to write that over here. Right, so the derivative of a to the x, what do we write it, a to the u, is equal to a to the u times u prime, natural log of that base a. So our base, right, I said is 3. So our derivative is going to equal our base to our u times the derivative of our u, so the derivative of v to the 1/2. Okay. That derivative is going to be 1/2 v to the negative 1/2. And then we times that natural log of a, so the natural log of 3. Right, let's see where those bases are. And where that u prime is. And that u. Okay, let's look at example 8. It says graph y equals the natural log of the absolute value of x in the coordinate plane at the right. And then for the right half of the graph of the absolute value has no effect. So the derivative of the natural log of absolute value of x is 1 over x for x is greater than 0. Okay. So I'm just going to draw that kind of graph in. Let's change colors. Something like this. Kind of something like that. Okay. So when I take the derivative of the natural log of x, when x is less than 0, we still get that 1 over x. Okay. So when differentiating the natural log function, the absolute value can be ignored. And it says in these cases, absolute value may change the domain of the function, but not our actual derivative. Okay, so let's look at example 9 here. Find the derivative of the natural log of the absolute value of 5 minus 2y cubed. Okay. So our u is that 5 minus 2y cubed. So we're going to take its derivative. Okay. Derivative of 5 is 0, so don't worry about that. Negative 2y cubed. I'm going to drop and multiply my 2 by my 3 and get a negative 6. Y stays there, drop the 3 by 1, and I get 2. So back to my derivative. We do our u prime, so negative 6y squared, over my y, so 5 minus 2y cubed. Okay. Let's go look at example 9. So it says, when possible, expand logarithms before differentiating them. So we're going to use some log information here. Okay. If I have the natural log or log, okay, of x times y, I can rewrite that as the natural log of x plus the natural log of y. That's a prog rule. There's a quotient rule, so the natural log of x over y. I can write that as the natural log of x minus the natural log of y. Okay. And then one that we saw kind of already, if I have the natural log of x to the a power, I can rewrite this as a times the natural log of x. Okay, so those are some things that will come in handy when we're looking at logs and natural logs. Okay, so example 10, differentiate y equals the natural log of x times the square root of 2x plus 1 over x squared plus 1. Okay, so first, on the top right, I've got x times the square root of 2x plus 1. So I can rewrite that as the natural log of x plus the natural log of the square root of 2x plus 1. And then we're minusing next because I have a quotient. So minus the natural log of x squared plus 1. Put that in parentheses. Okay. And then I can use that like power rule and rewrite the square root. So can do the natural log of x plus 1/2, right? Because the power on that 2x plus 1 is 1/2. So 1/2 times the natural log of 2x plus 1 minus the natural log of x squared plus 1. Okay, so now we can take the derivative of each piece. So kind of color code this a little bit. The derivative of the natural log of x is 1 over x. Okay. Plus, that 1/2 is going to kind of just chill out there because it's a constant. Okay. Then I have the natural log of 2x plus 1. So we're going to put that 2x plus 1 in the denominator. Take the derivative. So the derivative of 2x plus 1 gives me 2. Minus. Next, I've got that x squared plus 1. So denominator stays x squared plus 1. Numerator becomes the derivative. So x squared gives me a 2x. Okay. So ultimately, we can just leave it like that. Let's look at example 11. If y equals log base 2 of x squared plus 1. Okay. Let's make note here, right? We did kind of example with this. If we're taking the derivative of a log, yeah, let's rewrite that with our u. Then we get u prime over u times the natural log of our base. Okay. So ours is log base 2, so choose our base. All right, we've got x squared plus 1, that's our u. Okay. So y prime. So y prime is equal to the derivative of our inside, so x squared plus 1, so 2x, over our u, so that inside, x squared plus 1, times the natural log of our 2. Kind of color code some stuff here for you so you can see where it all comes from. Okay, right, and that natural log of 2 is a number. Okay, so I didn't finish reading out the rest of the problem, right? It says find y prime of 2. So we want to know what our value is when we have a 2 inserted. Okay, change colors. So y prime at 2 is going to equal 2 times 2 over 2 squared plus 1 times the natural log of 2, which gives me 4 over 2 squared plus 1, so 5, times the natural log of 2. Okay, but based on those log rules, I can rewrite this as 4 over the natural log of 2 to the 5th power, which is 4 over the natural log of 32, right? And the natural log of 32 is a number. But we're going to leave it like that because it's more accurate unless it asks us to find the decimal. Otherwise, that's what we're going to keep it as. Okay, that is all our examples. Make sure that with these ones up here that are highlighted, that you put those in your foldable or you make a flashcard, okay? Because these are ones that you need to remember.